use the booklet that we created in class today, and I want you to entitle it My Equation Book. And you can just copy these equations that I have on the front of my equation book and make it look exactly like this. Make sure that the staples are at the top so that you can flip it open this way. Now when you flip it open, you're going to cut the second page, the page right after the title, into 1, 2, 3, 4, 5 strips. And you're going to copy your vocabulary: terms, coefficient, constant terms, like terms, inverse operations, onto these 5 strips. Now, you would turn your book sideways so that you could see those. And when you open them up, you're going to have the definition on the inside. A term is a part of an expression, the parts that are added together. And so the terms here would be 7, 4x, and 5x, because those are all being added. So these would all be considered terms. Okay, and then next you have a coefficient. It's the number part of a term with a variable. And here's our example. And you are going to circle the coefficients. Coefficients, just the number part of a term with a variable. Since 5x has a variable, 4x has a variable, the number part would be the 4, the number part would be the 5. So these are called coefficients. Constant terms. A constant term is a number part without a variable part. So we have 5x plus 4x plus 7, and the number part without a variable, the only number we have without a variable is the 7. So this is a constant term. Like terms. Like terms are terms that you can actually add together. For instance, terms that are constant have the same variable part and same exponents. Those would be like terms because you can add them together. Let's look over here. So what terms can I add together here? I have nothing to add 7 with because there are no other constant terms. But I do have 2 coefficients that have the same variable part, and since they have the same variable part, these are like terms, and I can add those, and that would give me 9x. So like terms can be added together. Last, we have inverse operations. Inverse operations simply means 2 operations that undo each other. For example, the inverse of addition is subtraction, and the inverse of subtraction is addition. The inverse of multiplication is division, and the inverse of division is multiplication. So page 2 is our page that we cut into strips, and I'm going to turn this sideways again. Page 3 has our definitions and examples. And then we're going to flip the page. So the 4th page, I'm going to turn it sideways. And on the left, I write 1 step, and on the right I'm writing 2 step. This is where we're going to take notes on 1-step equations. This is where we'll take notes on 2-step equations. Now, we'll get to 2-step later. Right now, we're going to fill out the 1-step section. After you make your 2 parts, go ahead and cut them in half. So I cut this page in half so that I can open up the 1-step section. When I open it up, at the top, I have rules. These are the rules to a 1-step equation. The first thing you do when you're creating a 1-step or when you're solving a 1-step equation is you isolate king variable using inverse operations. Okay? You want to get your variable alone by using inverse operations or the opposite operation. Number 2, do unto one side what you do to the other. Let's look at this addition equation down here. We have 3 plus x equals a negative 6. Well, first of all, I got to find where king variable is. Is he on my right side of the equal sign or on the left side of the equal sign? King variable is on the left side of the equal sign. I want to get king variable alone by using inverse operations. Well, how do I get rid of the number that is with king variable, the 3? The only way to get rid of a positive 3 is to subtract 3. That becomes 0. Rule 2, do unto one side what you do to the other. So I'm going to subtract 3 from the right side. Negative 6 minus 3 is negative 9. X equals negative 9. To check that, I plug negative 9 in for x, and I get 3 plus negative 9 equals negative 6, and that's true, so it does check. Subtraction. Let's look at this subtraction example. M minus 7 equals 14. What's the inverse of subtracting 7? Well, first of all, when a subtraction sign's in the middle, I like to switch it, so that I can see that that is the same as a negative 7. Subtracting a positive is the same as adding a negative 7. Sometimes that is helpful, especially when you have a 2 or a 3-step equation and you're trying to find your like terms. You're trying to find what you can add together to simplify it. Okay, so we have a negative 7. How do we get rid of a negative 7? How do we isolate king variable? First, we find which side king variable is on. In this case, he's on the left side. And we want to isolate king variable by using inverse operations. Well, how do we turn this negative 7 into a 0? We add 7. And we add 7 here. That gives us 21. So m equals 21. How do we check it? We're going to plug 21 in for m. So 21 minus 7, or plus a negative 7, equals 14. And that is true. So it checks. Okay, now I'm going to turn the addition subtraction page that I have here, and I'm going to flip to the next page in my book, which would be page 1, 2, 3, 4, 5. I'm flipping page 5, looking on to page 6. At the top, I drew a line here, and I have multiplication. I'm going to look at multiplication. Again, this is a one-step equation, and I'm going to use the same rules I use for addition and subtraction. I have negative 6m equals 42. What's the inverse of what's happening here? Well, since this is multiplication, the inverse operation would be division. So I'm going to divide by a negative 6. Negative 6 divided by negative 6 is just 1. 1m, or m. I have to do the same to this side. 42 divided by a negative 6. Negative 7. So I have m equals negative 7. Now I have to check it. So I'm going to plug negative 7 in for m. Negative 6 times a negative 7 equals a positive 42. So it checks. And it's correct. All right, I go down here. This one has a fraction in it. Negative 3/4c equals 1 and a 12th. Well, this is multiplication. Again, I'm going to use the inverse operation, which is division. Divide by negative 3/4. Well, just like 4 divided by 4 is 1, 2 divided by 2 is 1, negative 3/4 divided by negative 3/4 is 1, 1c, and I have to divide 1 and a 12th by negative 3/4. To do that, I need to change this, this mixed number into an improper fraction, which gives me 13/12 divided by negative 3/4, and I need to stay switch flip. 13/12 times negative 4/3. I'm going to simplify the 4 and the 12, because 4 goes into 4 once and goes into 12 3 times. And I'm going to end up with a negative 13/9. So c equals negative 13/9. Negative 13/9 is the same as a negative 1 and 4/9. Now I can go back and plug in negative 1 and 4/9 and multiply it by negative 3/4 to see that I would come out with 1 and a 12th to check my answer. All right, division. M divided by 36 equals negative 2. Again, I'm going to isolate king variable using inverse operations. Where's king variable? He's on the left. I have to get him alone. What's the inverse of dividing by 36? Multiplying by 36. When I multiply by 36, the 36 cancels out. I'm going to multiply this side by 36, and I'm going to get a negative 72. M equals negative 72. I can plug negative 72 into the original equation, divide by 36, and I do get a negative 2. So it checks. Last one, negative 24 divided by m equals 4. Well, m is the denominator in this case. So whenever your variable is your denominator, you just use mental math. What number goes into 24 4 times? 6. So m equals 6. Oh, but if I check and put 6 in, negative 24 divided by 6 would give me a negative 4. So this has to be a negative, because a negative divided by a negative is a positive. So it works. All right, make sure that you have all of these copied into your foldable. Thank you.